So the other type of logs we're going to work with are natural logs instead of base 10 logs, where we were taking 10 and raising it to a power with base 10 logs. Now we're going to take e and raise it to a power. E is a number that we call by a letter, like pi, right? Pi is 3.14159, blah, blah, blah. Well, e has a value of 2.718 and all of those other digits. And so natural logs use e as the base. So pretty much everything we did back there with base 10 logs, we can do the exact same thing with natural logs. The one big difference is that we are using the adjacent button on your calculator on most calculators. We're going to be using the ln button with the second function of e to the x. So ln is the natural log, e to the x is the opposite function of the natural log. So I'm taking those exact same numbers from the previous calculator practice. I'm just doing the natural log now instead of the base 10 log. We will get different answers because the natural log uses 2.71 as the base instead of 10 as the base. So for the natural log of 42 on a standard scientific calculator, you would hit the ln button and then you would hit, you would hit 2 first. Sorry, 42 first. Let's reboot that. That was way too confusing. All right, to do this first example problem on a standard scientific calculator, you would type in 42 first, and then you would type in the natural log button. So let me do that on mine, 42 natural log, and that returns 3.74. For these remaining two in this column, I would just type the number in, 0.00125, hit natural log, and I get a negative 6.685. And for the last one, I'm just taking the negative of what we just found, and so that would be a positive 6.685. For the right-hand column with e to the 2.22, well, on your standard scientific calculator, you would show 2.22 on your display first, and then you would hit the second function key, and then the natural log slash e to the x as the second function key. Second e to the x, and that's giving me 9.207. And with the graphing calculator, or the scientific calculators that operate like the graphing calculators, which looks like I skipped here a moment ago, for this operation, you would hit the second function and then the natural log slash e to the x key, and that's going to open it up. There'll be your display will be showing e and then an open parentheses. Then you would type in the 2.22. You would close the parentheses and then hit enter. And back for the finding the natural log of 42, you would, on the graphing type calculators, you would hit natural log. And that's going to open it up with the open parentheses, and so then you would hit 42, close parentheses, and enter. All right, so for these two remaining examples, I'm going to type in 0.0222 and then hit second function to get e to the x, and that gives me 1.022, and last but not least, if I'm going to take e to the negative 2.22, I would type in 2.22, change the sign, and then second e to the x. That's going to give me 0.109. All right, one more set of practice problems here. just like we could solve an equation that said the base 10 log of x equals a number, we can do the same thing with natural logs. Just remember that natural log and e to the x are opposites. If you do it to one side of the equation, you have to do it to the other. So on the first example, I would raise e to the powers of both sides of the equation. So it'll be e to the natural log of x is equal to e to the 7.77. E to the natural log cancels out, leaving just x. And if I run that through my calculator, 7.77, second function e to the x, I get 2,368. Over on the other example, again, we're going to take e and raise it to the power of both sides of this equation. So e to the natural log of x is equal to e raised to the negative 2.75. E to the natural log cancels out, leaving x is equal to e to the negative 2.75. So 2.75, change sign, second e to the x. And I've got 0.0639 for an answer. Hopefully these are all working out smoothly and you've got this all covered. If not, definitely come see me in office hours, which are right after class this semester anyway. So come see me in office hours and we'll get things figured out for your calculator. Last slide. There are a couple properties of the log functions that are occasionally convenient. We don't use these a lot, but every once in a while, and it'll be convenient to have this. If you add two logs together, that's equal to the log of the product of the thing that you were taking the logs of. So for instance, if you have the log of 7 plus the log of 3, that's equal to the log of 21. Same thing if it's natural logs. The natural log of 7 plus the natural log of 3 would be equal to the natural log of 21. Then if you're subtracting two logs, if you subtract two logs, it's equal to the natural log or the log of dividing the two numbers whose logs you were subtracting. So if we had the natural log of 42 minus the natural log of 7, that would be equal to the natural log of 42 over 7, or 6. Ditto with base 10 logs. If we had the log of 42 minus the log of 7, that would be equal to the log of 6, because 6 is 42 divided by 7. And up here up in the top, 21 is 7 times 3. All right, that wraps it up for logs and natural logs.